Welcome to the next video in the series on linked lists. In this video, we'll see how nodes fit together to make a list. A lot of this information will be familiar to you. In this lesson, we'll revisit what a node is. We'll see how nodes fit together to make a linked list, and we'll look at the process by which we append, insert, and delete nodes from a linked list. So, a node is made out of two values: data, which can be anything, and a pointer. A pointer is an integer that tells the computer where to find the next item in the list. We could draw a linked list like this as a series of nodes joined by arrows. Of course, be aware there aren't really arrows inside the computer. All that represents, all the arrow represents, is that the pointer tells the computer a new data location, and in that new data location it will find the new node. The start of the list is called a header. The header is just a pointer, so in a typical computer program it'll just be an integer variable. It's a pointer with no data, and it tells the computer where to find the first node of the linked list. And then to find all the other nodes, the computer will follow the pointers, and so on. The last node in the list points to nothing. So we might write that as null or as none, for example, in Python. So we will follow the pointers until we get to a pointer that points to nothing, and that's the end of the list. So to recap, a linked list is made of nodes, and every node stores some data and a pointer. The pointers are integers that point to new data locations. That's how the nodes are joined together. The header is just a pointer. It's just the address of the first node. And the final node points to nothing, and that's the end of the list. Now, if we append a node to a list, all we do is we add it to the end of the sequence. Here's a very short linked list. It's literally only got one value in it, the letter A, and the pointer from A is null. But this same principle would apply to a list of 1,000,000 items. To append to the list, we have to create a node somewhere in computer memory that has the data that we want to add. The pointer is null. And then we alter the last pointer in our list so that it points to the new node. That's all you have to do. And now the linked list has been extended by 1. We call a linked list a dynamic structure because it can shrink and grow, and this is one of the ways that it can grow. The other way that a linked list can grow is by inserting nodes. That means adding nodes in the middle of the list. I don't know if you remember, but if you want to insert a node into an array, that can be quite difficult because there might not be room for it, and to make room you'd have to move all the other data items up by 1. But adding a node in the middle of a linked list is really easy, as we'll just see. Obviously, first create the node. So I want to change my linked list so that instead of going AB, it goes AZB. And now I change the pointers so that Z is linked in to my list. So now A points to Z and Z points to B. My linked list now goes AZB. Let's look at that again in slow motion so you can see what's happening. First of all, I'm copying the pointer from A to Z, so they're now both pointing to B. I have to do that first before I change the pointer from A. If I did it the wrong way round, I would lose the pointer to B. And once I've lost the pointer to B, I would lose not only that node, but the entire rest of the list. Could be millions of items. So I'm copying the pointer from A to Z before I make any other changes. That means the pointer is safe. I've got a copy of it before I overwrite it. Only then do I change the pointer from A so it points to Z. That's the only thing you have to be careful about when you're changing the pointers. Don't lose the pointer, because if you lose one pointer in a linked list, you lose the entire rest of the list. The computer just won't be able to find the nodes again. We can take advantage of that. If we remove the pointer to a node, that's the same as deleting it completely from the list. So let's say we wanted to delete the value A from the list. I only have to change the pointer. I change the pointer which did point to A so that it points to the value after A. That one change means that the linked list will now never visit node A, and it's effectively deleted. Notice that the computer doesn't have to wipe it out or overwrite it with null or anything. It just leaves it where it is, but the pointers no longer go there, and so it's not in the list anymore. So to recap, it's quite easy to make changes to a linked list, and most of it's done just by changing the pointers. To append, we make a new node and change the final pointer so that it points to the new node we've just made. Insert is very similar. We make a new node, but we have to change 2 pointers so that the new node is linked into the list, but the rest of the list is not lost. Delete is even easier. We change 1 pointer so that the pointers skip over the node that we've deleted. There are various advantages and disadvantages to a linked list compared to other data structures. It's dynamic and flexible. You can be adding and taking away nodes at any position. That's a big advantage over stacks and queues, and it's also an advantage over an ordinary array, where making changes to the order, inserting values in the middle can be a bit awkward and time consuming. You can use any available point in memory to add a new node, so it's quite a good way for the computer to use up bits of memory. It doesn't matter which bit of memory it uses. As long as it changes the pointers, it can add that bit of memory into the linked list. And to make those changes, you only need to edit the pointers. You don't really need to make any other changes, and now the linked list can be in a different order. It can add and take away. Of course, there is a disadvantage. You can't go directly to the different data values in a linked list. You've got to traverse the list. You've got to follow the pointers to get to the data values. So before I finish this video, I want to set you some work. There's a couple of slides here. So this one first. Draw an image of a linked list of 3 nodes containing the letters A, B and C, and then make these changes. Append D to the list, insert X into the list, and delete C from the list. Show how the pointers and nodes look after you've done all those things. If you want an extra challenge, and particularly if you want an extra challenge that's not programming, you could create an animated sequence of film, use PowerPoint, demonstrating how those changes would happen. You could do a voiceover. So that's just a bit of an extra challenge for somebody who wants extra work and they'd prefer to do something that's not programming today. However, there is an extra programming challenge. Now I've shown you how insert and delete work in theory. Can you write Python procedures to do these actions on a linked list? Don't worry if you can't, or if you try and it doesn't work, because I'm going to show in full in later videos. Anyway, thanks for listening. Have a go at that, and I'll see you in the next video. Bye.